Alright, this video is going to be on function composition. And that's closely related to the different function operations that we do. It's just a slightly different operation, and so I wanted to make it a different topic of study for us. So when we do composition of functions, it means that you are taking one function and plugging it into another. You are taking one function and plugging it into another. So for instance, we might have something written like this. And if we have it written like that, then what we would say is we are taking g of x and we are plugging it into every x value that we see in f of x. So we are taking g of x and plug it into every x value in f of x. Alright, and we're going to do some examples. And before we do the examples, I want you to leave a little bit of space because we're going to come back towards the end of this video and add something to these notes. So go ahead and leave maybe 2 or 3 lines, and then we can do some examples down here. So to start with, I'm just going to say we have our function f of x, and that's going to be 2x minus 3. And then we're going to have g of x, and I'm going to say that that is negative x squared plus 1. And we're going to have h of x, and that's going to be 2x squared plus x. Okay, so to start with, we're going to do just f of g of x, like what I just wrote. So f of g of x, we're going to say this is the problem that we're doing. And a good thing to do when you do composition of functions is just to start off by writing the outside function down. So this notation really means I'm taking g and I'm plugging it into f. That means that I'm starting with f of x. So I'm going to start off by saying f parentheses equals 2 parentheses minus 3. So I'm giving myself some space to plug in that other function. All right? Now in the problem they're asking us to plug g of x in, so I'm going to go ahead and write g of x is actually what I'm plugging in. And so this is me just writing down the notation, so the person who looks at my paper when I'm finished can say, oh, she plugged g of x in. And then over here, I'll actually do the work. I'll actually plug g of x in. And g of x was negative x squared plus 1. So I'm going to write negative x squared plus 1. There's my g of x right there. And so now I can go ahead and simplify the problem. Since this is notation, I don't need to do any math with it. I can just write it. But over here, I have this 2 in front of the parentheses, and I can go ahead and distribute that. So that leaves me with negative 2x squared plus 2. And I still have this subtract 3 on the end of the problem. And so I have a little bit more simplifying I can do. I have negative 2x squared. And then I've got that positive 2 and that negative 3, and that's going to give me a negative 1. So I know that that composition, if I plug g into f, would give me this as my final answer. Okay, let's go ahead and take h of x. We're going to let h of x be the outside function. And for the inside function, we're going to type f of x. Or write f of x because you're not typing. So h of x is going to be the outside function. F of x is going to be the inside function. So that means what I'm going to do is I'm going to start with the h, and I'm going to say h parentheses equals 2 parentheses squared plus parentheses. So anywhere I see the x, I'm just going to leave parentheses in its place. All right. Now f of x is what I'm plugging in. So f of x, I'm going to go ahead and write it right here. This is the thing that I'm plugging into this function. And so over here, I'm just going to write down what f of x was. So 2x minus 3 goes into this one, and 2x minus 3 goes into this one. And from here, this is just a simplifying problem. So I just have to be careful that I make legal math moves, that I'm not making any mistakes. So on this, that's notation. I don't have to do anything there. Here, I'm going to go ahead and write this 2. I can't do anything with it yet because I want to take care of this exponent first. So because of that exponent, that means I'm going to write this parenthesis twice. 2x minus 3 gets written twice because it had an exponent of 2. Now this parenthesis on the end, I put it on the paper so that it would be easier for me to write down what I was plugging in. But if you notice, there's no number here that needs to be multiplied. There's not a minus sign that I need to distribute. There's no squared. There's nothing outside of these grouping symbols that tell me I need to do something to them. So that means that at this point, that 2x minus 3, nothing needs to happen to it. So I can just go ahead and write it down without the grouping symbols. I don't need that anymore. So here, what I'm going to do next in the problem, and there's a few steps you could do, but what I'm going to ask you guys to do is to multiply these two things together. So we're going to do this first. That will be our normal classroom procedure. It's not the only way you can do this problem, but I find that students make less mistakes if we're consistent. So we're going to go ahead and multiply those together. I'm going to go ahead and do the box method for multiplying these off to the side. So if I multiply 2x times 2x, 2x times 2x, that gives me 4x squared. And then if I do 2x multiplied by negative 3, 2x multiplied by negative 3 is negative 6x. And then if I do negative 3 multiplied by 2x, then negative 3 multiplied by 2x is also negative 6x. So those together, I can see would be negative 12x. So I'm going to go ahead and write that down. And then I have negative 3 times negative 3. Negative 3 times negative 3 gives me 9. So that's what I got from doing all this stuff right here. And then I can't forget, I did have a 2 in front of that parenthesis, so I need to write that. And I still have the 2x minus 3 on the end. All right, now at this point, I want to be able to get rid of these parentheses as grouping symbols. And so I can do that by taking that 2 in the front and distributing it to the problem. So that's going to leave me with 8x squared minus 24x plus 18. And I'll go ahead and drop down that part on the end. There's no math for me to do there. Just writing it. And at this point, we are ready to finish the problem. We just need to combine like terms, and then we'll be all done. So I've got 8x squared, and I have a negative 24x and a positive 2x, and that leaves me with negative 22x. And then I have a positive 18 and a negative 3, and that gives me positive 15. And so that's what I get when I do the composition. All right, now we're going to go back up to the top, and we are going to write down how you verbally say this out loud. So this is f of g of x. So we're going to say f of g of x. That's how you say that out loud. And this is where the other notation comes from. If you guys recall, when we were doing function operations, we always had the normal operation. This is how we would probably think of it, and this might be how a mathematician might look at it because they're being too lazy to write both x's. So this is another way of thinking of it, but this is what it really means. We have the same thing with function composition, and this is where the function composition notation comes from. They say f of g, and they write it like this. They say f of g, like that, and then they say of x, of x. So f of g of x. And you'll notice the primary difference between this right here and multiplication is that when you do multiplication, there's a little tiny dot and it's black. it's filled in. Here, you're going to see a circle. It's a small circle, and it stands for the word of. So f of g of x. And sometimes people will even go so far as to say this is fog. So just be careful of that. The other notation looks kind of silly, and this is what they're actually saying, is they're using it kind of from how you say it when you say the words out loud. All right, so that's composition. You're taking one function, you're plugging it into another function.